have Frederic from Hummink already online. Hello.
Hello.
Yeah, Vice President of Business Development project. And yeah, we're going to talk about technology for sub-micron accuracy and alignment in microLED manufacturing. And you have the floor.
Thanks a lot. Thanks a lot, and thanks for the opportunity to present the technology and the company. Then first element is to present this technology of high precision capillary printing, HPCAP, which is brand new. As you can see, the first IP was filed in 2018. The Hummink company was founded in 2020 by Amin Embarki and Pascal Bonsen. And very quickly, end of 2022, we sold our first machine, installed first machine, and now we spread the technology. And 2023 and above, we are going to continue to spread and to go to some HVM qualification and the worldwide expansion. Then to explain you the technology, what I'm going to do is to show you a video. Christophe, if you can put the video from the beginning. Thanks a lot. Then the technology is based on atomic force microscopy. If you are familiar with this technology, basically what you have is that you have some vibration that is applied to a resonator. And instead of using a metallic element like the atomic force microscopy, we replace that by a pipette with some ink inside. And we monitor continuously the frequency. And according to the frequency, we are able to position exactly the pipette on the Z position and to follow the printing continuously, as you can see here, if you have some slope, if you have some roughness. Then very good control with this technology, and then we are able to do many things. Then here is an example of some decoration. We can do some repair for the display, for the semiconductor, for many kind of things. We are able to control very precisely, and I'm going to explain that in more detail, but especially the gap between the elements. And we are also able to do some micro bumps with some very impressive aspect ratio, because I'm talking here of micro bumps that can go to 20:1 aspect ratio, meaning a 10 micron diameter and 200 micron height, then very, very high. And we can play with different aspect ratio. We can do substrate with different dimensions. For the dimension, then we use pipette with different diameters from 50 micron to 100 nanometer, which is the smaller pipette we can work with. And we can do the deposition of many different kind of things: metal, polymer, quantum dot, which are important for the micro LED. And we have the tool. We also are working on modules that are going to be integrated for the high volume manufacturing. Okay, thanks for the video. Then thanks a lot. I'm gonna come back to the flow. Then we can work with any kind of material, any shape, any surface. You see here the micro bumps that were presented. We can do array of micro bumps and it's very interesting, especially for flip chip application, for repair also, because we are able to put micro bumps. If you have an array of micro bumps with some missing elements, we are able to put very precisely the micro bumps here. Interdigitated electrodes, dots, lines, then many different kind of things that can be done. For the micro LED, because that's the topic of interest today, micro LED adoption is something that is coming. There are some challenges, of course, and then if you see here the comparison between different technology, clearly the micro LED has a lot of benefits. Brightness in terms of many contrast and many things compared to the OLED or the LCD. But the point that is the challenge is really on the maturity and the cost. But there are a lot of progress right now that are done to make the adoption of the micro LED something real and something in mass production. Very interesting in this micro LED world is that you already have some application that requires to go